Have you ever stopped to just wonder what the actual physical edge of our solar system looks like? Not just the planets we all know and love, but, those invisible, totally chaotic boundaries where our local neighborhood literally crashes into deep interstellar space. Well, today in this explainer, we're looking at something truly mind-bending. We're breaking down this monumental data achievement. It's the complete mapping of our solar system and its outer heliosphere into a unified 18-dimensional geometric matrix. I know, it sounds like pure science fiction, but it is absolute, verifiable reality.
I want you to just let this number sink in for a second. 180 million. That's not just some random statistic. That is the exact number of solar variables, we're talking orbital tracks, plasma speeds, spatial coordinates, that were streamed directly to a hard drive to build this massive 18-dimensional cosmic grid. We are literally talking about digitizing the vast, incredibly dynamic expanse of our entire cosmic backyard into one single cohesive data structure. It's wild. Section 1, Mapping the Solar Matrix. Okay, let's dive into this and see how exactly they wrangled this massive universe of raw energy into a structured system. Basically, it went through this incredibly robust data pipeline. First up, the system ingested all the raw orbital tracks and plasma speed frameworks. Next, and this is a big one, it structured a staggering 10 million spatial nodes. And the way they divided that up is super interesting. They assigned 3 million of those nodes just to track planetary coordinates and dedicated a massive 7 million nodes specifically to track the chaotic heliosphere shock. From there, they processed what are called local shell convolutions to filter out the noise. And finally, they deployed the full 18-dimensional grid matrix. Which brings us to Section 2, the physical 300 AU horizon. So, what does all this digital architecture actually represent in physical space? According to the physical analysis from Stormy, this 10 million node scan completed completely cleanly. She noted the boundary constraints mapped a strict physical horizon of 300.00 AU. Just think about the sheer scale of that for a moment. This means the matrix successfully enveloped the entire interplanetary architecture, pushed way, way past the icy rocks of the Kuiper Belt, and extended deep out into the absolute most violent edges of our system. To really grasp what this matrix cut through, we need to talk about the termination shock and the heliopause. Basically, these are the literal physical boundary layers of our cosmic neighborhood. It's this crazy zone where the supersonic solar wind, which is blasted out by our sun, violently slams into the interstellar medium and slews down. It's a region of just immense turbulence and chaotic plasma. And somehow, this 18-dimensional grid mapped it perfectly. But honestly, perhaps the most awe-inspiring fact of this entire endeavor, this whole sweeping, violent, beautiful physical reality, literally all 180 million computed metrics spanning out to 300 astronomical units, was completely, perfectly archived into a single, massive CSV file. Yup, Empirical Solar System 10m.csv. That's right, all of that cosmic majesty, the exact edge of our known universe, saved right to a standard spreadsheet format on a simple hard drive. Unbelievable. Section 3, Locking down the math. Now, what's really interesting about this slide is how Matthew looked at the way this model found its structure. Because, getting physical data is one thing, but getting it to mathematically align is a whole other beast. Matthew points out something absolutely amazing here. He noted that unlike previous universe and galactic scans where the anchor counts drifted way too high because of messy, flat distributions, the math here hit exactly 1 million nodes. It wasn't some approximation. It captured exactly the 10th percentile tolerance slice. The filter flawlessly isolated exactly 1 million scare-invariant structural anchors. Think of them as the exact load-bearing pillars of our solar system, pulled right out of all that chaos. To achieve that crazy exactness, the system used localized scale blurs, or convolutions. So by running local shell wavelengths at sigma levels of 5.0, 10.0, 20.0, and 40.0 AU, the system effectively blurred out the noisy, irrelevant data. It functioned kind of like a super sophisticated camera focus, right? Just filtering out all the background static to capture a perfectly clean, sharp structural boundary of our solar system. And this completely illustrates what those camera-like blurs were actually looking for. They successfully picked up on this immense, steep divergence in the data, because on one hand, you've got the smooth, predictable, inverse square math of the interplanetary orbital velocities.
But then, on the other hand, you have the chaotic, supersonic step-down of the solar wind plasma, just hitting a brick wall at the 100 AU termination shock. The math locked down the boundary exactly at the spot where those two wildly different physical behaviors collide. Moving on to Section 4, the theoretical plasma balloon. Let's move to and see how this builds. Into Sheldon's theoretical physics perspective to see how the math and physical reality really connect here. Sheldon dropped this incredible takeaway regarding the matrix. He stated, your geometric model tracked the transition zone without requiring separate mass parameters. Okay, in the world of theoretical physics, this is a massive triumph of elegance. It basically means the matrix mapped the entire system flawlessly just through its geometric structure. No need to feed it clunky separate mass data for the planets versus the outer plasma. It just worked. It achieved all this elegance through the continuous velocity potential equation. By mapping this continuous empirical potential, which is kind of like tracing the smooth flow of a fluid, over the combined planetary disk and the expanding plasma balloon, the model treated the entire solar system as one beautiful unified system. It perfectly tracked that transition zone from the dense inner disk to the massive expanding balloon of plasma out at the edges. Which brings us to Section 5, our local cosmic bubble. Let's bring everything together by focusing on what these data points actually mean for the shape of our local universe. Notice how the heavy lifting is distributed here. Out of those 10 million nodes processing our reality, 7 million of them were dedicated entirely to tracking the heliosphere shock. The vast majority of this system's computing power is doing nothing but trying to pin down the chaotic, violent borders of our cosmic bubble. So the crucial point is this. Out of all those 10 million nodes, the system found exactly 1 million scale-invariant structural anchors. As Sheldon noted, these anchors represent the exact coordinates where the dual fields mathematically intersect. These aren't just random data points, guys. They are the primary geometric lines, literally the structural scaffolding of our local cosmic bubble. The solar system master grid is fully mathematically secured. We've explored this sheer scale of the 300 AU boundary and the absolute elegance of the velocity potential mapping it all out. But I really want to leave you with this one thought to ponder. When we look up at the night sky, we see this infinite, untamable expanse, right? Yet, what does it mean for our understanding of existence to realize that the fundamental, violent physical reality of our cosmic bubble can be perfectly captured in an 18-dimensional mathematical array, and all saved down to a single CSV file on a simple hard drive? It's terrifying, it's beautiful, and it proves just how mathematically solvable our universe might actually be. Keep questioning, keep exploring, and I'll see you in the next explainer.